Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice math Olympiad complex power problem or a complex exponential power problem. So that the very first thing we are going to do is here we have 1 plus iota and its whole power 23. We will find the value of this expression. So that here first we will just take its base equals to z. So here you have our base is z equals to 1 plus iota, and now the very first thing I can convert this nice exponential number into the polar form. We can convert this exponential number into the polar form, and you know that the polar form of a complex number equals to z equals to r into cos theta plus iota of sine theta. I can name this as equation number 1. So this form is called the polar form of a complex number. So now first I can convert this complex number into the polar form. So in order to convert into polar form, here we need only two values. The first one is r and the second value is theta. So now we will first solve these two values. So the very first thing, here you know that our r equals to z mod. It means that we will just take the absolute value of z. It will be equals to r. So our z equals to 1 square plus 1 square and its whole square root. So that here you get r equals to 1 plus 1 will becomes square root of 2. So this is the value of r. Here I can substitute here, and now in order to find the value of theta, we will just use its formula. Theta equals to tan inverse y over x, and you know that we have an exponential function in standard form is x plus iota y. So this is the standard form of complex number. So that here you have the value other than iota is x and the coefficient of iota is y. So that we will put here, here you have x equals to 1 and y equals to 1, and we will put these two values here, and you will obtain tan inverse of 1 over 1. So it will becomes tan inverse of 1, and you know that the value of tan inverse 1 equals to pi over 4. So this is the value of theta, and now we will just put the values of r and theta in equation number 1. So here I can write equation 1 becomes, so our equation number 1 is z equals to r into, here you have first time r, so we can just put the value of r, which is square root of 2, and cos of theta, and the value of theta is pi by 4, plus iota sine theta, and the value of theta is again pi by 4. So here we can just take, because here you have the exponent of 1 plus iota is 23, so that here we need to take 23 power on both of the sides. So that here we take z power 23 equals to square root of 2 into cos of pi by 4 plus iota into sine of pi by 4 and its whole power 23. Because our question is that we will need to solve 1 plus iota whole power 23, so that here I can take, so here you will put the value of z, and here start of the problem we put z equals 1 plus iota, so it will becomes 1 plus iota and its whole power 23. So here we can separate the power 23. So first I can write 23 power on here, and then we can take 23 power on this one. Cos pi over 4 plus iota sine pi by 4 and its whole power 23. In the next step, we will use here a very famous De Moivre's theorem of complex numbers. And you know that about De Moivre's theorem, you know that if we have cos of theta plus iota sine of theta and its whole power n, it is equals to cos of n theta plus iota times of sine n theta. It means that if you have some exponent of cos theta plus iota sine theta, it is multiplied by the angles of sine and cosine, so that we will use here this nice De Moivre's theorem. So according to this theorem, we will multiply this 23 on the angles of sine and cosine, so that it will becomes square root of 3. And now I can break this square root of 2 and its whole power 23 as square root of 2 and its whole power 22 and square root of 2, and here we multiply this 23 on each of the angle, and you get cos of 23 pi by 4 and plus iota sine of 23 pi by 4. So now we can just use De Moivre's theorem here, and you get its output in this form. And now here when you multiply this exponent by square root, then it will becomes 2 to the power of 1 over 2 times of 22 into, here you have square root of 2. And now we can write this 23 pi by 4 as cos of 4 pi plus when you break it, you get 4 pi plus 7 pi over 4 and plus iota sine of 4 pi plus 7 pi over 4. So it will becomes in this form. And now in the next step, you will get here, these are cancelled by each other, and you get 2 times of square root of 2 into here we have, because 4 pi be the quadrantal angle, so now by the trigonometric ratios of allied angles, here we use the concept of trigonometric ratios of allied angles. So according to this one, we will just ignore this quadrantal angle, and you get cos of 7 pi over 4 plus iota sine of 7 pi over 4. And now here we need to find the value of cos 7 pi over 4 and sine 7 pi over 4. So now we can put these two values here, and you get 2 times of square root of 2. Sorry, here you have 2 to the power of 11, because when you cancel these two one, you get 2 to the power of 11. And now you have cos 7 pi by 4 equals to 1 over square root of 2, and sine 7 pi by 4 equals to minus 1 over square root of 2. So we can put the values of these two one here, and now we multiply the square root of on each of the sides, and you will just get here. So here you have 2 to the power of 11, and it is equals to 2048. Here you can find the value of this by using the calculator, and when we multiply this one here, then you will get 1 minus iota. So in the left hand side we have 1 plus iota and its whole power 23. So this is the our final answer of this problem, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.